In case anyone's wondering, this is more of a history lesson than anything else about, trivial movement and copying. If it's, I don't see them down there as well, about trivial movement and copying. So, hopefully that matches your expectations of what you came to see. We'll find out if it isn't. Quick question about who I am. I work at Bloomberg, based in Ireland. Lots and lots of C++, been doing it for the last couple of decades or so. And almost all of that has been various finance companies with a couple of FANGs in there. One thing I didn't mention on here is I also a member of the WG21 committee via the National Standards Association of Ireland. Right, what I'm going to talk about. Now, quick. Firstly, a bit of a, why do we care about trivial relocation? What is the actual problem that we're going to be looking at? If there isn't a problem to solve, there's no point in doing something. Given that we have a problem at the moment, what are the various third-party libraries doing as workarounds for this? And what attempts have there been made in the past, and there's quite a few, to solve this particular one? And what's going on at the moment? What's likely to happen in the future, if it's possible to predict that? And obviously, any questions at the end. Right, so I may be assuming too much knowledge. I may be assuming woefully little knowledge in the first part of the presentation. So if you know all of this already, then, please bear with me for the next little while. So, there we are, pulmonary triage, short history lesson. So imagine, for the sake of argument, we have a little class, my class. It could be a string, it could be whatever. It's some sort of user-defined class. We have a vector of that class, and we push four of those objects onto the vector, and then we push a fifth onto the vector. So I am working on the basis here that we have a fairly simplistic vector that uses exponential growth by doubling the number of elements in its capacity. I know implementations may vary, but I picked the simple case for the sake of discussions. So basically, we essentially need to increase the capacity of vector. So the old-fashioned way is we would allocate enough space for, in this particular implementation, double the number of elements. So we're going from 4 elements to 8 elements. Copy the elements down one by one into the newly allocated memory. Then we destroy the elements that already existed. So if my class is, for example, a string, each of those copy constructors would result in an allocation, and each of those destructors would result in a deallocation. Short string optimization ignored for the time being for any pedants in the room. So it destroys those, swaps the pointers, deallocates the old memory, job done. So essentially, we have done 5 allocations. So if my class is a string, we've basically done 5 allocations and 5 deallocations, which is quite inefficient. Hence, C++11 gave us move constructors. Same scenario. So if the object has a move constructor, that is no except, then it is safe to use move construction when we're growing the vector. Again, fairly simple. Like I say, I'm racing through this first part of the talk, so if anyone needs me to slow down a little bit, shout. Same scenario, need more space, allocate the new data. We move each of the objects. We destroy each of the previous objects. Now, by moving the objects, the destination object takes ownership of the resources. So we're effectively just changing the values of pointers within the move constructor. When we destroy the old objects, the pointer is null anyway. Again, working on the assumption my class is something like a string. And So that's basically no op, so it's much, much faster. Again, swap the pointers, destroy the old data. So for every move construction, so if we have a vector of unique pointers, for example, for every move construction, there's 3 pointers to be set. For every destruction, there is 1 pointer to be checked. I know we can pass a null pointer into the deleter. I'd put that check in here primarily to make it clear what is actually happening in this scenario. So that is much faster than the 03 version, but the question is, can we do better? Can we not just basically copy the bytes? You know, essentially take the old, allocate the new, run memcopy, swap the pointers, deallocate, job done. And if we look at the individual operations that would be required by that, you'll notice it's essentially all of that is replaced by one call to memcopy, which, to be honest, is usually pretty well optimized as it is, depending on the platform. So again, looking at unique pointer, growing a vector. So I did a quick test using vector of unique pointer. If you look at the assembly for the move construction-based growth compared with the assembly for the memcopy-based growth, it's much simpler. The slight elephant is that it does involve a call to memcopy, but again, that is a reasonably well optimized. Similarly, vector of string, much simpler. And doing a vector of string, I did a quick benchmark, so I hacked implementation of vector just to see if actually growing the vector was much quicker using memcopy rather than the move construction approach. And there was a factor of 2.8 speed up in vector growth. So it's actually, in that case, is actually fairly significant. The fact that I did it on string is somewhat notable, I guess, as we'll see later. So the question is, can we do so? If we want to just copying the bytes, is that allowed, or are we going to blow anything up? So this is where there is a concept called trivially copyable. Now, trivially copyable in high-level terms essentially means that it is perfectly safe if you want to copy an object to just use memcopy on that object. So, and one of the requirements of being trivially copyable is a concept called trivially destructible. So the destructors of that object can be entirely skipped. And most vector in fact, every vector implementation I know about at the moment, if a type is trivially copyable, we'll optimize using memcopy for a vector of that type. Now, for anyone who's interested, I'm not going to go through these slides. This is how the standard defines trivially copyable. You will notice it's quite difficult. There you go, carries on. And there's various sub-definitions you can go into. It's quite difficult to get for a type to be trivially copyable. In fact, I would say that the vast majority of types I use day-to-day in production within vectors are not themselves trivially copyable. You know, any virtuality, any polymorphism, any non-standard member types, any constructors, destructors, assignment operator, anything other than basically the rule of zero or setting things to default is going to break trivial copyability, and vector will then fall back to using move construction. So typical type that, this type, for example, is trivially copyable. If it gets much more complicated than this, it probably isn't. And notable types that are not trivially copyable, which are many of the standard types, such as a string, unique pointer, that people want to store in vectors. Vectors of strings are common. Vectors of pointers are common. Vectors of, even a simple pair or tuple is common, but it is not trivially copyable, so there is no, you don't get any optimization there. Again, as I pointed out earlier, most vector implementations will, if something's trivially copyable, they will use memcopy. One of the arguments I'm going to make is that there are many, many types for which it would be perfectly safe for vector to grow its capacity by means of memcopy that do not fall into the trivially copyable camp. So there are many, many optimizations out there that are simply being missed. So if the standard library doesn't do it, does anyone else? What do other libraries? Can you actually take advantage of this using other libraries other than the standard library that came with your compiler? So I'm going to define a term for you that I'm going to probably use quite a lot for the rest of this talk, namely trivially relocatable. So I'm going to say that a type is trivially relocatable if, in order to move it from one place to another, it is safe to do so using memcopy, provided that you do not, under any circumstances whatsoever, attempt to then call the destructor on the original source object. So, for example, if I talk about a string, for example, so if I memcopy a string, you will have two objects that have pointers to the same allocated memory. If you destruct the source string, you've deleted that memory. The destructor deallocates that memory. And therefore, we end up with a string holding a pointer to a dangling pointer. So, but if you are if you can guarantee that you will not attempt to destruct the source string, you're safe. You can happily, okay, string has a big gotcha, say a unique pointer. You can guarantee that it is entirely safe to just memcopy that unique pointer. I'll talk about string. Just as a quick demo of what I'm talking about, trivial relocation is, you memcopy it, delete the source, as opposed to allocate the memory, call the move constructor, call the source destructor. In this case, the destructor is important. It's important that you actually do call the destructor. And I'll talk about object lifetimes in the standard and how they apply to this shortly. So, what do third-party libraries do? Can we actually take advantage of this concept using third-party libraries? So I'm going to talk about Facebook folly first, mostly because I work at Bloomberg and I thought it would be I didn't want to put BDE first because that would be showing favoritism. So with the Facebook folly library, it uses memcopy for trivially copyable objects, same as the others. However, if you have a type, say widget or whatever, and you know, because either you are the author of widget or you've inspected the code in widget, that it is safe to trivially relocate a widget, you simply do a partial specialization of the isRelocatable template, and FB Vector will then use memcopy afterwards and optimize this for you. Oops. Yeah. Bloomberg's BDE. The approach, in fact, you find the approach with all of these libraries is very similar. You have to indicate that a particular type is safe to be memcopied, and then Vector will do so. BDE is done by either a partial specialization or there's an appropriate nice little macro you can use. Many other libraries, I think EASTL has one. Qt, you've got a macro that you can pop in and it will be trivially relocatable. Job done. So, pretty much every library that takes advantage of this by indicating that a type is trivially relocatable, there are a bunch of common themes. So you have to manually decide which types can be trivially relocated and indicate that fact for those libraries to actually take advantage of it. Standard library types. Now, it might be very tempting to say, okay, I'm going to, say that unique pointer, put the macro in and say that unique pointer and string can safely be trivially relocated, therefore my vectors of unique pointers and strings will work wonderfully. However, you will notice in libc++ stud string, one of the members is a pointer to another of the members when you're using short strings, the short string optimization. So if you're building against libstd++, you can quite safely say string is trivially relocatable. If you're using libc++, you're opening yourself to a world of pain. So you need to be quite careful. If simply taking a third-party library or container or things within the standard library and saying these things can safely be trivially relocated. And there's a bit of an elephant in the room because what these libraries are doing by using memcopy for types that are not trivially copyable is, technically speaking, according to the standard, undefined behavior. There we go. So if you look at the standard, then if you have an implicit lifetime type, you can safely relocate that using memcopy, and you know that the lifetime of the new object will safely exist, and the lifetime of the new object will have officially begun, and the lifetime of the old object will have ceased. So compilers and optimizers have to respect that. Whereas if a type is not trivially copyable, doing so is technically undefined behavior, and some future compiler or some future optimizer could take advantage of that and start eliding operations and break your code. However, we're lucky at the moment in that none of our current compilers actually track all of these operations to an extent where the optimizer is going to walk all over them. But because it's undefined behavior in the standard, there is no guarantee that it might not happen in the future. So, is there any point in doing this? Because it sounds like it's an awful lot of effort. One of the things of note is that I would say the vast majority of types that I've come across in production can be safely trivially relocated. It's only when you start doing peculiar things like having a type that holds a pointer to another member of itself that trivial relocation becomes problematic. So by having a mechanism whereby the language itself supports trivial relocation is going to provide optimization for an awfully large proportion of the types that you would want to hold say, in a vector. Whereas the current reliance on trivial copyability, the vast majority of types simply cannot be relocated. Again, this is essentially a copy of the previous slide, just emphasizing, here's a bunch of common types, and, with the obvious exception of string, all of these would be entirely safe to trivially relocate. And depending on which particular proposal goes into the standard, that will either be found automatically or standard library writers would have a means of flagging that up. So, why doesn't the standard itself support trivial relocation? So this is the final bit where we start talking about the old history. Start talking about a history lesson. Let's keep an eye on time. Okay. Now I'm going rather faster than I thought. So I suspect we're going to have a lot more time for questions at the end, if there are any, or a longer break. So the very first attempt was done in 2014 by a guy called Pablo Halpin. He is a member of the BDE team, and the proposal he put in for the standard was very similar to the approach that BDE currently takes. It's called Destructive Move. There's a link. You can view the paper he wrote there. Again, it was based very much on the BDE library approach. Pablo's paper also talks about doing relocations for where such a relocation is not trivial, but because I'm only focusing on the trivial relocation aspect of this, I'm going to gloss over that particular aspect of his paper. So, Pablo proposed two type traits: trivially destructive movable and no-throw destructive movable. This was in the days before the phrase trivial relocation had even entered the popular vocabulary. And he argues that if something is trivially move constructible and trivially destructible, it is therefore trivially destructive movable by default. You'll notice the difference here that I talked earlier about trivially copyable, which is what a lot of containers currently rely on. Technically, trivially move constructible and trivially destructible are themselves weaker than trivially copyable. So this would cover slightly more types by default than the current vector implementation, than the standard library currently covers. Brain's not working. I got these slides in slightly the wrong order. I'll talk about this, then go back. Okay. There is a new standard library function was proposed as well by Pablo, saying that uninitialized trivial destructive move, which basically calls memcopy. But it calls memcopy with a very important difference. There is a guarantee, there would be a change to the wording of the standard to say that the lifetime of the new object would technically have begun and the lifetime of the old object would technically have ended as a result of this call. Essentially getting rid of the undefined behavior problem. So, and this particular function can only be called if the previous trait, trivially destructive movable, as defined there, is true. So if a type meets the requirements of trivially destructive movable, this trait is true, and this function can then therefore be called, and it will call memcopy under the hood. Now, as I say, I got these slides slightly in the wrong order. And if you have a type and you want to say, I know in my heart of hearts that it is very safe to relocate widget, you would partially specialize is trivially destructive movable. That trait is true, and therefore uninitialized destructive move would use memcopy. And the other part of this proposal is that the various standard library containers that need to relocate a type would use, where possible, uninitialized destructive move, and therefore memcopy. So it will be part of the standard that we could indicate widget is indicate widget is trivially relocatable and leverage the optimizations by simply partially specializing this particular template. There's various reasons it didn't progress. The committee at the time was loath to adopt the changes to the lifetime model. There was a very strong opinion at the time that the lifetime of a user-defined object should be tied to construction and destruction. And because constructors and destructors were not being called, there was reluctance to progress with this. There was a subsequent proposal, which you can go and look at, which actually suggested a new syntax for constructors and destructors. So you could have effectively a type of constructor and destructor that would start and end the lifetime of an object, but would not actually do anything. Again, that didn't necessarily, progress in committee, but the minutes and the paper are all online if anyone cares to look. So there was another attempt. So after Pablo's paper bid farewell, there was another attempt by Dennis Bider. So this is a different approach, is that he proposed that as well as having a copy constructor and a move constructor, every type can also have a relocation constructor. This is the double arrow syntax is the one proposed in his paper. I'll let members of the audience judge for themselves whether they like that or not. So you would call this, and basically, the idea being is that there will be this particular relocation constructor would be defaulted if there are no special member functions at all in your class. So if you essentially follow the rule of 0 on your class, you would get a default relocation constructor, and the default relocation constructor would itself call memcopy. There are, complications because, as we've noticed in subsequent proposals, it is possible to have a class that doesn't have where you follow the rule of 0, where it might not necessarily be safe to use memcopy on it. But this was the initial revision of a proposal, and I'm sure these little glitches in there would have been solved with subsequent revisions had it progressed through committee. There would be a type trait that anything could use. So if you have a defaulted relocator or relocation constructor, or if you have a relocation constructor equals default, then is trivially relocatable would be true, and the trivial relocation would actually be, as we'll see, trivial relocation would then be memcopy. Sorry, I missed off on this. The other thing of note is that the compiler, and again, I didn't mention this in the slide, in this particular proposal, if you move construct an object and the source object is immediately destructed, then according to this proposal, the compiler would be free to use the relocation constructor as it wished. So types that simply relocated a single object around would not, according to this proposal, have to test and call memcopy. Anything that needed to move an array of objects around would have to test the trait, have to call memcopy, essentially off their own back. Now, there's two notable things about this proposal. This is the first proposal that actually has a set of rules whereby the compiler looks at a class and says, can this be trivially relocated? Every, Pablo's previous proposal and all of the current third-party library implementations, you have to go in and you have to indicate my type is trivially relocatable. This is the first one where it actually tries to, to essentially work that out on your behalf. This is also the first time that the phrase trivial relocation actually came into being that I was able to find. I'm sure Alistair at the back of the room will correct me if he knows of an earlier instance. Again, this failed for, the initial proposal was put to committee, and there were various, various non-technical reasons why it didn't progress. So again, you know, the minutes and the blog posts and everything are all online if people want to, you know, are interested in that. So, third attempt, Niall. Niall proposed move equals bit copies. Now, Niall's working on lightweight exceptions and zero overhead deterministic exceptions. So the motivation, Niall's motivation behind this was possibly slightly different. I think optimizing vector growth wasn't his primary motivation, but you know, it would have been, you know, a useful side effect of this paper. So what Niall's suggestion was is we have another keyword, bit copies. So on your move constructor, you pop an equals bit copies. So instead of having equals default on your move constructor or having a user-defined move constructor, you have equals bit copies, and then every single move construction would actually call memcopy rather than rather than doing a member by member. I can't say it. Member by member copy. I should have brought a glass of water. And it's also, he's quite emphatic that it should be as if memcopy. So the compiler is allowed to elide any memcopies it wishes. A new type trait, so which enables you to detect whether a type has an equals bit copies move constructor. So a library such as vector can test the type trait and call memcopy and grow its vector accordingly. And there's also a proposal that you can have equals bit copies auto, whereby the compiler would then decide whether to use memcopy or whether the move constructor would be a memcopy move constructor or a member by member move constructor, you know, a la default at the moment. Though it doesn't actually go into details as to what the underlying rules for that determination would be. I think that was left to a potential future revision of the proposal. Now, the other thing of note with this particular proposal is it actually requires 2 memcopies to move a single type. So in order to specify an equals bit copies move constructor, you have to be able to trivially construct your type. Your trivially default constructor, your type has to have a trivial default constructor. So essentially, a compile time instance of the type is created. When you copy, when you do a move, there is a memcopy from your source object to your destination object, and then another memcopy from the compile time default constructed object into your source object. So essentially, because the source object is then effectively a default constructed object, it would be safe to call the destructor on that object. Hence, that is the reason he had the second memcopy on the proposal. Obvious limitations. You cannot have a type which is, you cannot distinguish between move construction and relocation in this proposal. So if you have, say, if you have a type which cannot be move constructed using memcopy for whatever reason, but can be relocated using memcopy, then you can't flag it. You cannot flag it as such with this particular proposal. The proposal explicitly bans virtual inheritance, but no one uses that anyway. And again, as mentioned, the type must have a context for default construction. Okay, I think that should be trivial default constructible. Okay, based on the proposal. So I've made a mistake on that slide there. Apologies. Again, for unrelated reasons, this went in 2020 and didn't go beyond that. So I'm going to talk about the fourth and the fifth attempts together, because the fourth and the fifth attempts are ongoing. So in 2018, someone called Arthur O'Dwyer put a proposal in for trivial relocation. And in 2023, myself and Alistair at the back of the room put in another proposal for trivial relocation. In case any one of you were wondering why I'm actually giving this talk in the first place. So, because these two proposals are very, very similar, there is a huge amount of overlap between them. Those are the appropriate links. 1144 went in 2018. It is current. This presentation was based on revision 6 of the paper, but a revision 7 has now been submitted with a new title, actually, so the title is out of date. 2786 was introduced in the ACCU meeting earlier this year, and the next revision is in progress. And these are still working its way through committee, whereas the previous ones are, they will not be, they're not going any further. I guess theoretically the authors could resurrect them, but I'm not aware of any attempts by them to do so. So, notable about these papers is we both are of the opinion that trivial relocation is the important one. There is a case of non-trivial relocation and, the possibility of relocation constructors, but you don't really get the optimizations from that than you would get from trivial relocation. So trivial relocation is really the only thing that we're talking about. And both of the papers are in agreement that the object lifetime model needs to be updated, as was mentioned in Pablo's paper as well, in the standard. Both proposals, even though we discussed possible standard library changes, neither of these proposals are proposing standard library changes. The idea is that we would add the relevant core library features and maybe a handful of standard library functions needed so that implementers of standard libraries could take advantage of these and perform optimizations. There may well be a case for changing the standard to changing the standard library sections of the standard in the future, but that is something to be considered once we get the core language features in place. Reference implementations. There's Arthur's paper. He has a reference implementation in CLang, I believe, and he has also created a version of the standard library that takes advantage of this. There's a Godbolt link that shows you an example piece of code running with that. The standard library version of the mine analysis papers is in progress. It's being worked on. It's not far off. It's being worked on. So, simple commonalities. Anything trivially copyable is by definition trivially relocatable. That was an easy one from the start. If we had things that are trivially relocated, that are trivially copyable but not trivially relocatable, then we've obviously done something wrong because we are essentially making vectors slower. So they're both in the agreement of what we mean by doing a trivial relocation. You can copy the bytes as long as you do not, under any circumstances, call the disruptor. on the source object from where you have copied the bytes. And the third point, if it is safe, you can create a move constructor and a destructor with side effects, and then mark the type as trivially relocatable. That is probably something you want to be really careful about doing, because you will find that under some circumstances, your type will be trivially relocatable and you will not get the side effects. Whereas under other circumstances, libraries may choose to do a move and destroy operation, and you do get the side effects. So I'm not going so far as to say it's undefined behavior, but it's something that you need to be aware. If you have got move constructors and destructors, and calling them move constructor and destructor is not equivalent to copying the bytes, you need to be aware that here be demons. There are both provide type traits, named slightly differently in both proposals, but the naming is essentially, a cosmetic thing. Both have is trivially relocatable, which I'll show you the definitions for trivially relocatable on the next slide. Arthur's paper also has is relocatable, which means that you can call the move constructor and the destructor, and is no for relocatable, which means that you can do so without exceptions. In my analysis papers, we didn't bother. We didn't provide that type trait. It is, to be honest, I'm not entirely convinced that there's even a use case for those two particular type traits. There is a syntax. So if you have a widget and you know your widget is trivially relocatable, you can flag it as such, either with an attribute or with a keyword, depending on the proposal. I think the attribute versus keyword is more of a cosmetic difference. So, realistically, if the standard library committee wants one or the other, it's not, I don't think any of us are going to argue particularly strongly for one or the other. And now the trivial we both have functions that we provide to enable trivial relocation. And there's very differences. There's a strong difference of opinion as to what those functions should actually do, as we'll see. And there's a bunch of convenience wrapper functions as well that both proposals are suggesting that people can use. You will notice that one of the later papers' utility wrapper functions is called relocate, which happens to be the same name as one of the more fundamental functions provided by Arthur's paper. It's an unfortunate clash of names rather than the fact that they're the same function. So, definitions between, now I'm not going to go through all of these. Well, I can if there's time later. So essentially, if you are missing various special functions in Arthur's paper, then the compiler will automatically determine that your type is trivially relocatable. Same in ours. There was a slight issue that was noticed with P2786. If you are using SFINAE to allow for multiple versions of your, using SFINAE to decide between which particular version of your special function is being used. So this wording is going to be tweaked slightly in the next revision to sort out that little ambiguity. So the question is, what's different? What fundamental aspects of these two proposals are different? We are cautiously optimistic that one of these proposals, or some combination thereof, will find its way into the standard. And so the question is, so these are the types of decisions that have yet to be made either by the authors of the paper between themselves or by the committee when deciding what to allow in. There's a general difference in tone between the two papers. P1144 is designed to be more usable by people who use C++ day to day. It provides functions that take iterators. The relocate function is perhaps more user-friendly. The paper itself doesn't have as much detail as to how some of these particular functions will be implemented. The latter paper, P2786, we focus solely on the key changes to the core language that will be needed. Other key difference, again, utility functions. Now, I mentioned the relocate function. Now, the interesting and somewhat fundamental difference between the two between relocate in Arthur's paper and trivially relocate in P2786 is if it is safe to call memcopy, i.e. if a type is trivially relocatable, then Arthur's relocate function will call memcopy. Otherwise, the relocate function will call the move constructor and the destructor within the body of the function. And it is up to you, if you care which one is called by the relocate function, you would have to check the type trait yourself before you call the function in order to know what it's going to do. Trivially relocate in the more recent paper will only do trivial relocation. It will only call memcopy. And you will notice that it is constrained in the oops, wrong one. Where's it gone? There. Trivially relocate is a constrained function. If it is not safe to relocate your type with memcopy, you will get a compilation error. And that's one of, I guess, the fundamental differences between the two types. The other thing is Arthur's paper is based on, there is a fundamental assumption that trivial relocation must be equivalent to move and destroy in Arthur's function. So it explicitly states that in the paper, and the move constructor and the destructor must be publicly accessible. So if your constructor and destructor are not publicly accessible, you will not be able to mark a type as it would not be possible to trivially relocate in Arthur's paper. It is possible to mark a type as trivially relocatable, but yes, trivially relocating is undefined behavior in Arthur's paper. However, the P2786 cares more about the members and base classes of the type. So we do not require that. Don't worry, I'll get to this thing. One of the key difference here is that we do not require that the constructors and destructors be public, and we do not require that there not be a user-defined assignment operator. This flags up one of the fundamental differences between the two papers is that the 1144 treats move assignment as being in scope. So you'll notice that in the definition I showed earlier, in order for the compiler to assume a type is trivially relocatable, there must be no user-defined move assignment operator. Whereas in P2786, move assignments are completely out of scope, and we do not. you can put user-defined assignment operators in your classes to your heart's content, and it will not impact trivial relocation. So, given the definitions, for example, there's a bunch of types that we would consider to be trivially relocatable because of the lack of a dependence on an assignment operator. And there are a bunch of types that Arthur's paper, let me go through them in detail. So, because there's a difference of opinion between ourselves and Arthur, I know there was a discussion prior to this presentation, but our opinion is that PMR, all of the PMR containers which require where there is an assignment operator, can be trivially relocated under the later paper, because we do not assume that trivial relocation can be used to replace assignment. Whereas P1144 does, because it assumes that trivial relocation can be used to replace all assignments, or move assignment and destruction, it would not be safe to use that version of trivial relocation in P1144. Now, there is a difference of opinion because Arthur has asserted that it is safe to use P1144's trivial relocation in PMR. So, in the interest of openness, I'm pointing out that there is a clear difference of opinion there that has yet to be argued out. Similarly, and equally on the later paper, one of the conditions of marking a type as trivially relocatable in P2786 is that you absolutely have to have all bases and members also being trivially relocatable. So if you have a member of if you're a member of your type is from a third-party library that is not marked as trivially relocatable, then we would prevent you from marking your type as trivially relocatable, whereas P1144 would not, it would let you happily go ahead and do so. Why is it going twice? So, P2786, essentially, if you look at the definition earlier, we are quite restrictive. If you do not satisfy the requirements for trivial relocation, if you do not satisfy a number of conditions for trivial relocatability, namely, for example, you must not have virtual inheritance, your bases and members must themselves be trivially relocatable, then we will treat it as an error if you mark your class as trivially relocatable. It will break compilation. We want to avoid having ill-formed behavior wherever possible and undefined behavior wherever possible. P1144, has a philosophical difference. The idea is that you can safely mark pretty much anything as trivially relocatable. It will be ill-formed. In most cases, ill-formed, no diagnostic required. And you can merrily go ahead and trivially relocate, even though it's going to be problematic to do so. Again, there is a philosophical difference between the two authors as to how we should be behaving with these things. Again, there's the different assumptions. P2786 treats assignment as completely out of scope, which means swapping is completely out of scope. Trivial relocation, if P2786 goes in, can only be used for move constructor relocation. That's it. So essentially moving things around within a container, such as a vector. The latter point swapping P1144 may be removing swapping from the paper. There's a blog post where he's currently trying to work out whether he has found that there is a case where using relocation for swapping is fundamentally broken. And that might be sufficiently serious that swapping gets removed from 1144. Again, the question is, is it safe? Again, this is the question of, is it safe to use assignment as opposed to, is assignment equivalent to simply doing a move construction and destroying the original? Are there cases where there's an assumption in the 1144 paper, because assignment, you can use trivial relocation for assignment, that these must be equivalent? The other thing is that for moving objects within a container, a PMR container, it is safe to assume that those objects have been created using the same allocator. And therefore, we can use trivial relocation in almost all situations where sometimes within a vector, move construction and destruction is used to relocate an object. Sometimes move assignment and destruction is used to relocate an object. And it is because within a PMR vector, those objects will have been constructed using the same allocator. It is, as far as I am aware, always safe to replace those particular assignments with trivial relocation as well. But not in the general case of any assignments. Right, what happens now? So, I guess we've covered the main similarities and differences. I said the final papers went on for slightly longer than expected in this talk. The current suggestion is that both of the paper's authors work together and attempt to move their papers to more of a common ground, if at all possible, before going back to the evolution working group in WG21. Obviously, there'll be a bunch of commonalities, a bunch of irreconcilable differences for the committee to look at. So both papers were, reasonably well accepted by, the evolution working group, EWGI, at WG21. So I think there is a reasonable possibility that one of these two or some combination of these two will eventually make it into C++. I don't want to say C++ 26 because that will be far, 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 far too optimistic given the speed at which these things move. Maybe 29. General conclusion, what have I said? Basically, what we really need in the language a way to enable containers to move their members around using memcopy. It would give a huge optimization and it would be incredibly valuable. That's you will notice by the sheer number of third-party non-standard libraries that have put this particular optimization into their vector implementations, just how valuable it has proven to the writers of those libraries. There have been a plethora of proposals. I'm sure there have been a number of smaller comments and papers that I haven't spotted in my search. These are the main ones that I've come across. To enable this, to actually extend the standard library itself to include this feature. And again, we're trying to get it in. So think of this more of as I guess if you look at the two papers, something like something akin to what you see in these papers will will be in the language at some point for you to use. Just don't know when and exactly what it's going to look like yet. Right. Any questions?
Thank you for the talk. I'm curious whether standard library types such as unique pointer can be... I'm curious whether standard library types such as unique pointer might be retrofit with being marked as relocatable, or whether that's going to be an ABI break or something that cannot be done in a backwards compatible manner.
Well, something like a unique pointer would, as far as I'm aware, meet the requirements for the compiler to, assuming the current, I'm going to talk more to the paper that myself and Alistair wrote because I'm more familiar with that particular proposal as opposed to Arthur's. I am not aware that any ABI break would be required. Yes, no, they should, because they're essentially, yeah, because essentially it's a template, a template implementation. So, yes, take that.
So in terms of ABI, this is not something that will enter mangling because it's a property of the type or not, and it will just reason about how compilers can optimize and perhaps for meta programs. So it's not an ABI break in that sense, but if you link together code that was created before and after this came in, you might be violating ODR. Some implementations might have now optimized differently. So it's just the same as building with your compiler with a different set of optimizations available. Is that ABI compatible? What's your definition of compatibility at that point?
Finish the question, so is there going to be any practical obstacle for standard library implementers to make a bunch of types trivially relocatable, and we should just get the benefits by switching to C++26 or whatever?
That will vary by library. As Mungo pointed out, the libc++ basic string cannot apply this today, and making a change there for their library would be ABI incompatible if they wanted to make their type today supported. But for the vast majority of types in the standard library, we believe that this can be a quality of implementation, and it becomes a question how much of that quality of implementation we would want a follow-up library proposal to mandate it's important that these types are trivial relocatable.